In this video, I'll try to go over a couple more examples of how to deal with negative exponents and simplify them. And I'll select questions C and F in the hopes that we can condense our work a little bit and start to make this a little bit easier for ourselves. Remember in the previous video, I had talked about the idea that you could essentially use the flipping thing as a bit of a shortcut, so that instead of doing the formal reciprocal thing with the two steps, you can sort of condense those two steps in one. I'm going to use that strategy again in letter C. Now the thing in letter C that I want to make sure that I notice here is the inclusion of parentheses, because the parentheses sort of complicate things in a way that I didn't have to deal with in the previous examples up to this point. For instance, on the top, x cubed y to the negative second is being squared, which in a very literal way means that I actually have two of those x cubed y to the negative second. And I'm going to write that out just so I can visualize it. X cubed y to the negative second is going to be written once, and then it's going to multiply another x cubed y to the negative second, because that's what square means. It means there's literally two of those things. And since each of those items will be written twice, I can see it all there. X to the fourth didn't have that, so I'm going to leave the x to the fourth on the bottom. Now let's think again about the idea that we had just discussed in the previous video about keeping versus flipping things. Anything with a positive exponent is going to stay where it is, and anything with a negative exponent is going to move. So I'm just going to go turn by turn, and I'll show you my strategy so you can kind of tell how I like to do my work in case this helps you as well. For example, x cubed is going to stay where it is because it has a positive exponent. So it was already on the top of the fraction, it's going to stay on the top of the fraction x cubed. Now I'm also going to lightly kind of scribble that out just so I can tell as I'm working like which things I've already dealt with versus which things I still need to deal with. So I like to scribble out lightly. Some people highlight, that's fine. Some people don't bother, they just keep track of their work. It's up to you. I like to do the scribbling thing though, because I like to just kind of keep track. It's hard when you have lots of terms to remember which ones you've dealt with and which ones you haven't yet. So the scribbling thing helps me, but that's just personal preference. Now I'm going to do the next term, y to the negative 2. Negative power, so that means it's going to flip. That y is going to flip to the bottom of the fraction and become positive 2 for the exponent. So we'll scribble that out to show that I've dealt with it. It flipped to the bottom. Its exponent became positive because it flipped. Now the next term I need to deal with is x cubed. It has a positive exponent, so it's going to stay where it is. It's going to stay on the top because that's where it already was. The next term is y to the negative 2. Again, that has a negative power, so it's going to flip to the opposite location. It's currently on top, so it's going to flip to the bottom. And the exponent becomes positive. Again, I'll clean it up later. I'm just doing all the taking care of the terms and putting them in the right places first. Then I clean it up later. Now, the last term I need to deal with is x to the fourth. It has a positive exponent, so it doesn't need to go anywhere. It's currently on the bottom. It's going to stay on the bottom, x to the fourth. Now, technically, this is a complete answer. This is actually fine as an answer because you've actually accomplished the goal. Remember that the goal in this question is to simplify, and simplify just means write everything with positive exponents. We have technically done that. We now have all positive exponents. It just looks kind of awkward. So I like to clean it up a little bit just so I don't have to write so many things, and I think I'll clean it up in the following way. X cubed and x cubed is really 3x's and 3x's, so a total of 6x's, x to the sixth on the top. Y squared is 2y's and another 2y's, so that's 4y's, y to the fourth. And the x to the fourth that's on the bottom is not a like term, so it doesn't combine. But then I can notice, hey, x to the 6 on top, x to the 4 on the bottom. X to the 6 on top is literally 6x's. I'm just writing them out lightly so I can visualize them. X to the fourth on the bottom is literally 4x's. And again, I can visualize them. I can picture those x's canceling out. I can cancel 1, 2, 3, 4 of them off the top with 1, 2, 3, 4 of them all off the bottom. And what that leaves me with is simply 2x's on the top, or x squared on the top. And that same y to the fourth didn't do anything because it didn't have any like terms, so I would leave that on the bottom and just call it y to the fourth. So I know my cleaned up answer is x squared over y to the fourth. Perfectly fine. Now, one more quick thing to acknowledge, especially for those of us who are actually fairly well versed in the rules of exponents, is that you may have looked at this and said, Herbert, That's totally inefficient. What are you doing? You could have done this faster. And some of you are exponent savvy and may have realized something that actually could have bypassed a couple of these steps in the middle. If you're familiar enough with your rule of exponent or rules of exponents to know that in this parentheses situation in the original problem, whatever number inside the parentheses represents the power of x does technically multiply the power it's being raised to on the outside. So for instance, on this top part here, I could have bypassed some steps and said, hey, wait a minute, that multiplication rule applies. When I have inside powers and outside powers, I can multiply the inside times the outside power. So x to the power of 3 times 2 outside would be 6. And y to the power of negative 2 times 2 would be negative 4. And that clears the parentheses off the top so that you don't have to deal with it. The x to the power of 4 didn't have any parentheses on the bottom, so it stays that way. Now you'll notice if I do the problem this way, I do have to still do the keeping and flipping thing because I have a negative exponent there. X to the 6th can stay where it is. Y to the negative 4th has a negative power, so it flips to the bottom, becomes y to the positive 4. Took care of that, took care of that. Now I need to keep x to the 4th on the bottom. And now I've taken care of all the terms, so it looks like my answer is pretty good. And sure enough, if you simplify this answer, you'll end up with the exact same thing I've already written in the box. And what's interesting is if you compare my work that I just did on the scratch paper to what I did on my original train of thought, you can definitely tell it's a little shorter, perhaps more efficient to use that rule of exponents with the multiplying thing. So it's up to you. If you don't know your rules of exponents very well, you can do it the longer way, and hopefully it'll make sense why you do it that way. But if you know your rules of exponents fairly well, you can certainly take some shortcuts, and you can use those shortcuts to help. The reason I'm pointing that out, of course, is for something like letter F, that shortcut may be a valuable strategy to consider. So here's what I would do if I was doing question letter F and wanted to just be a little more efficient about it. Not to do it the long way, but to try to expedite things a little bit. I would start out by saying to myself, okay, I have a power outside. That's going to multiply whatever powers are inside. But it's important to note that the rule is about multiplying powers, not numbers. I'm not multiplying negative 2 times 2. I'm multiplying negative 2, the outside power, times whatever the inside power is. And it's important to note that 2 and x are separate as exponents go. 2 is to the power of 1 and x is to the power of 1, but those are actually two completely individual elements. Each of them has its own exponent, because an exponent's like a counter. This is like saying we have 1, 2, and 1x. And it's those individual exponents for which the exponent rule applies, the multiplication rule that I discussed as being a shortcut. So here's how I would do this. 2 to the power of 1 is being raised to the power of negative 2. I can multiply those exponents together, so that gives me 2 to the power of 1 times negative 2 is negative 2. Then I can do the same thing from, actually let me give myself a little bit more space here so that the previous question's not in the way. 2 to the power of negative 2. Then I'll do the same thing with the x. X is to the power of 1 times negative 2, so that's x to the power of negative 2. That clears my parentheses because I've used the multiplication rule, so the parentheses are gone. Now I still have y to the 5th. I'll copy that. I still have on the bottom 2, which I'm still going to write to the power of 1 just so I can get used to those numbers as individual elements that are not attached to x's or y's or any specific letters. Those numbers aren't directly attached to anything. Those numbers are just part of the question. Just like x and y are detached from each other, the 2 is detached from everything as well. So give it its own exponent, and sometimes that helps trick your brain into seeing it detached. X cubed is detached and y to the negative 1 is detached, but I'm seeing those things and reminding myself here, ooh, I need to flip some stuff. I need to use the negative exponent situation that we've got. So let's see what we can do with a negative exponent. I don't have a lot of negative exponents that I can use, but I can do some of them. 2 to the negative 2, that's a negative exponent, so that means it flips down to the bottom, becomes 2 to the positive 2. I'll cross it out to show I dealt with it. X to the negative 2, also a negative exponent. That'll flip to the bottom, become x to the positive 2. Get rid of it. Y to the fifth is already a positive exponent, so I'm not going to move it. It's already on the top. It'll stay on the top. It'll stay y to the fifth. Okay. On the bottom, 2 to the power of 1 has a positive exponent. It's not going to go anywhere. It's still 2 to the positive 1. Now, I put a little times dot there just to show whatever's left on the bottom is all going to multiply itself. Same thing as whatever's on the top is all multiplying itself. So I'm just putting the times there as a reminder, but you don't have to put the dot. Anyway, 2 to the power of 1 stayed. X to the power of 3 still positive, so there's no need to flip it. X to the power of 3 stays. And y to the negative 1 is negative. So since it's currently on the bottom, it needs to flip to the top. Y to the positive 1, and I've dealt with all my terms. Now I can do a bit of cleanup, just so I can see what I'm working with here. Y to the fifth, y to the 1, that would be y to the sixth if I combine all those y's together. On the bottom I have x squared and x to the third, that's x to the fifth. But I have these numbers. 2 squared is 4, 2 to the 1 is 2, and those are technically multiplying. All of the individual elements on the bottom are all multiplying each other. So 4 times this eventual 2 would be an 8 on the bottom, if I would just want to clean them up so they express as one number. You could also call it 2 cubed. If you want to think of it as 2 2's and another 2, that's 3 total 2's. So you could call it 2 cubed if you want, whatever you want. But this looks like it's about as cleaned up as it can get. The exponents are positive. I don't have any more like terms to combine, so I'll say that my final answer is y to the 6th over 8x to the 5th. Now, generally speaking, this is just a lot of rules of exponents all in one. It's the negative rules, it's the occasional zero power, it's rules of exponents from Algebra 1 where you're allowed to combine things or use things like that multiplication strategy. So just try, if you can, question letters D and E using what you know about exponents combined with some of these new strategies if it helps you make things more efficient. Also try question number 8. Question number 8 is giving you 4 examples of somebody trying to solve a specific question, but 3 of the 4 examples are wrong in some way. Some mistake was made. So the question is really twofold. The first task here is to figure out which of these was done correctly, and then figure out in each of the wrong ones where they went wrong. What rule did they execute incorrectly, or what rule did they misunderstand? So between now and the time you start the next video, try to finish number 7, try to make some sense of exponents, try to think about number 8, and again make some sense of exponents, because on the next page you're really just going to do more practice. You're not going to learn anything new on the next page, so that's why it's so important to really make sure here and now on number 7 and 8 that we understand, that we feel like we have a good solid foundation so that we can continue to build in a way that is actually constructive and that will allow you to keep strengthening those skills slowly, one step at a time, rather than build it all at once.